let's try to learn slope of a line in this video here. And actually slope is going to be a very important tool actually in differentiation or derivatives, right? So let's make an attempt. I'll take the simplest case to begin with. Let's say you have, that is my y-axis, this is my x-axis, and y, that is negative y, that is x, and this right here is your negative x. Let's say I have this line here. Let's say the line I have is something like that. It's a straight line, right? So with a standard equation of y is equal to mx plus c, mx plus c, right? And you already know that the slope of the line would be m in this case, but we are not here to discuss that. We're trying to understand the meaning of this, right? So let's say you choose two different values of x in this. So I don't know, let me choose this value of x and call it x1, and the corresponding value of y, I'll call it y1. All right, and then I'll choose one more value of x, I don't know, somewhere here. Let me call that value as x2, and the corresponding value of y, let it be y2. All right. So if I really join these points, what I'll be getting is, if I basically join these points, I think I'll get something like that. So this right here is y2 minus y1, or otherwise known as delta y, and this right here is x2 minus x1, otherwise we can call it as delta x. Delta is little change, it's change actually, right? And before I get into like how do we write slope and all that, you've already learned the first thing they teach you about flux is actually flux of any line is tangent or tan of theta the line makes with x-axis. So let's say this angle right here is theta, then you already know that slope is going to be tan theta. So tan theta is the slope of this line, right? That we are already familiar with. I'm actually not liking myself right now for using tan theta for slope, but anyway, I think that is going to help me explaining this, right? So yeah, anyway, let's continue. Also, if you see this little white triangle right here, right? This triangle, if you see between delta y, delta x and the green line, I think even this angle is theta, right? So because it's a parallel line, or these two are parallel lines, x-axis and this little white line here is a parallel line, and therefore that angle will also be theta. And if I try to write the value of tan theta from there, if I try to write the value of tan theta, it will be, what is tan theta? We already know that tan theta is opposite side of a right angle triangle divided by adjacent side, right? So if I use that to this theta, what is opposite side? Delta y. And what is adjacent side? Delta x. So you can always write slope of a line, and you already know that tan theta is slope, right? So slope of a line, you can also write it as delta y divided by delta x, or as you would write, you already must be knowing this formula, y2 minus y1, which is delta y basically, divided by x2 minus x1, which is delta x basically, right? So that's slope right there of a straight line. Fine. So finding slope of a straight line, you've already done enough problems about these in your junior classes, right? But what if I have a curved line? This was a slope of a straight line, pretty simple, seemed familiar. But what if I have a curved line? A line something like this. Say y is equal to, or maybe I'm going to use f of x. F of x is equal to, basically it's like y is equal to only. So f of x is equal to x squared. What if I have that line, right? And y is equal to x squared, or f of x equal to x squared is actually a parabola, but you don't have to worry about that too much right now. But if I were to draw that, it would look something like this. It would look roughly like that, touches x-axis, and it's symmetric on either sides like that. It's a parabola, right? So that's parabola right there. Now the question is, how do you find the slope of this line or any line? Basically, you know, you can have, if not this, you can actually have any function which could eventually give you, I don't know, maybe that curve right there, right? How do you find slope of a curve? For that is, we'll try to make an attempt. Okay, I wanted to say something, but yeah, I'll say that later. So let's try to make an attempt in that direction, right? We're trying to find the slope of this curved line right here. We really can't do, but we'll try to improvise on whatever we already knew. What do we know? That I'll choose 2 points of x, and then we'll choose 2 corresponding values of y, and then I'll try to, you know, use this little equation right here, y2 minus y1 divided by x2 minus x1, or delta x by delta y by delta x. We already know that that is going to be slope. Not really for curved lines, but let's see how it works out if I take that, for instance, right? So to begin with, I'll take these 2 values of y. I'll take, let's say I take this point and this point. So let this point right here be my x1, let this point here be my x2, right, to begin with at least, and the corresponding values of y, so this right here will be your y1, and corresponding value of x, I'm taking rough values here, somewhere here would be my y2. All right, now, and so yeah, now if I join these points, if I join this point right here, this is basically y2 minus y2 comma y1, y2 x2 y2, I'm sorry, this point right here is x2 y2, and this point right here is x1 y1, right? So that they are the coordinates of that point. If I go with the basic definition of y2 minus y1 divided by x2 minus x1, I'm going to have to, you know, in fact join them first, and then this portion right here will become my delta y, and this portion right here will become my delta x. So, you know, strictly going with, if I were to use the good old law, that is delta y by delta x. So this right here is delta y, and this right here is going to be delta x. Great, worked out well for us, right? But can I really call this a slope of the curve? Not really. I can't really call this slope of the curve, because I'm thinking, no, slope basically is what how steep is a given line at a given point, right? That's what the slope is. And clearly, you know, if you were standing here, let's say it is you who's standing on this curve, right, you would find it very difficult to, you know, in fact stand here than you would find it to stand here, right? So these 2 different points have different slopes actually. So I can't really go on and say that delta y by delta x itself is my slope of this line. I can't really do that. However, what I can in fact try is maybe decrease the distance between x2 and x1, you know, try to reduce this a little bit. You know, it looks like a large difference, and therefore the corresponding value of y also turns out to be very largely away from each other, right? At least in this case, right? So I'll try to reduce that distance. Let me try that. So once again, I have same curve. We're not going to change the curve. We still have the same curve. So you have your x-axis and y-axis, and we have our, I'll try to draw the curve which is almost similar to that one, because I'm trying to explain the same curve. Yeah, let's go with this. It should do. And except this time what I'll do is I'll choose a smaller values of x1 and y1, I mean x1 and x2. So let this be my x1, let this be my x2, and then corresponding values of y. So let this will then be the y1, and then somewhere here close to this, yeah, somewhere there will be my y2. And if I now join these 2 points, somewhere here is my x1 y1 now, because I'm choosing different values of x1, and this right here is x2 y2, x2 comma y2 is that point. And if I join these points now, join these points with a straight line, and then that becomes your delta y and this becomes your delta x. Is this the slope of the curve then? No, not really again, but because once again you'll notice this, that it is still steeper over here compared to this point. So I'm not really getting at the slope, not able to get at the slope right now. But what if I make it further smaller? You know, the distance between x2 and x1, I make it further smaller, right? So it's going to get even smaller than this. Maybe I'll draw a very rough diagram this time. Yeah, let's say this is x-axis, y-axis. You have your curve is going to be messy this time. Yeah, you have your curve. This time what I'll do is I'll choose points very, very close to each other, much closer than previous case, maybe like that, right? Then I'll maybe I'll choose 2 points which are pretty close to each other, and then I'll join these 2 points. You know, this time I kind of see the difference in steepness was very much large here. In the first case, I'll go back to first case a minute, please bear with me. In this case, look at this. This point is very steep. This point is very steep, very difficult for you to even stand there. This is almost horizontal, so not a problem. Slope is very less here, right? This point looks like, you know, if you were to stand here, you would somehow manage that, but if you try to stand here, it will be very difficult. So very steep, less steep. The difference in steepness between this point and this point was very large in first case. Second case, yes, it was still large, but much less compared to case 1. Let's call this case 1, case 2. In this case, the difference in steepness, in this case right here, the difference in steepness is much less, right? Would you be able to stand here at this point right here? Maybe not, but easier than that, right? And here still difficult, but yeah, comparatively easier. So difference in steepness is less here. If I notice in present case now, if I notice at this point and this point right here, the steepness difference is much less. So the point I'm trying to make here is that I can't really call this as slope. No way. The first graph is far from being a slope. Whatever you will get by doing delta y by delta x, whatever it is that you get by calculating this is definitely not slope. Definitely not slope, right? Is this the slope then? Not really. Is this slope then? Not really. But you know, I am getting at least the steepness of this point and this point, I'm getting them pretty close to each other. I think you know what I'm getting at here, right? Let's see. So what I'll do now is, I seem to be getting better and better results. Not really results, but we are reaching somewhere, right? So what I'll do finally is, I'll choose this point as x1. Let me zoom that a little more for you. Right, so I'll choose this point and call it x1, and then very as close as possible. I can't even, it's literally the very next point. Like it's the same point except with a small difference. But for that, I'll choose one point here, call this point x2. I'll call this point x2, which actually is x1 plus a very the smallest value you can imagine. x1 plus a very small number, the smallest real number you can imagine, right? That's what x2 is. And the corresponding values of y therefore will be, let's say this is this right here becomes your y1, and very near to that the corresponding value of x2 is going to be your y2, right? And therefore, and now if I do the good old technique that I'll join these 2 points, if I join these 2 points now, the steepness of this point and this point look pretty much the same. They are not literally the same yet, but yeah, I can in fact, now I hope you're getting at what I'm trying to get into. If I make this value very small, then x2 is very close to x1, and therefore you are not really dealing with two different points. You are actually dealing with just one point on this curve. And at that point, if I were to zoom this and redraw it, if I were to zoom this and redraw it, it would look something like this. I'm zooming it, and that's why you see all this, right? This point right here is your x2 y2, and this point right here is x1 y1. And even after zooming, the points are so close that the line you choose to draw, to connect these 2 points will actually lie on the curve. This is after zooming, guys, by the way. This is after zooming and all that, right? And this right here now is delta y, and this side right here is your delta x. And now you can actually talk about the slope of this point. Zoomed version is this. The unzoomed version would be it would just look like that. Unzoomed version, the normal version would just look like as if you just have a point, a single point, right? And then if you connect those points, the little line that you have been drawing to connect these 2 points is actually going to be just more like a tangent to that point. We'll talk about that more later. And now it really makes sense that you can find the slope of this line, and that becomes the slope of that point. I hope you're getting what I'm trying to tell you, right? Fine. So that's how you actually find the slope of a curved line, that you make the difference between the two independent variables so small that you end up joining the 2 points on the line are actually just 1 point, and then that right there becomes the slope. Right? Fine. So I hope that helped, and actually it's going to be really interesting the next video. If you have followed what just happened in this video, the next video is going to be very interesting. I'm very excited about the next video actually. Right, so I'll stop here. I hope that helped. Thank you.